Good morning, database. Professor Niffin here from my home office. It is Friday, March 16th, and today we're going to have our unit on relational algebra. We will cover unary operators, and then we will have a unit on binary operators. Today is day 16, and we will be covering relational algebra. It may be useful to consider relational algebra to be a bridge between what we've done in the first half of the semester and SQL. So consider it as a precursor to SQL. Relational algebra can be found in chapter 11 of the textbook. This diagram is just showing all of the different operators found in relational algebra. So for example, there are two unary operators, the project and select operator. And then for binary operators, there are Cartesian product, there are three set theoretic operators, there are divide, and then there are several join operators. This chart and the data that are used in the upcoming examples can be found on page 540 and 541 of the textbook. And in fact, this content isn't completely new or shouldn't be a complete surprise to you all. We did briefly introduce relational algebra on days 9 and 10. And as a reminder, there are two unary operations, selection and projection, and we will be discussing those at length during this video. In addition, there are 6 binary operators: union, intersection, difference, join, Cartesian product, and division. And we will be discussing those on our next video. This can be a helpful way to remember the effect of the selection and projection operations. So in this diagram, under selection, we see that we obtain a subset of rows by using a selection operation. In contrast, the diagram under the projection operator demonstrates the result of a projection operation. That is, we would obtain a subset of columns when we use a projection operation. For the next several slides, we're going to focus on the select operator. And as previously mentioned, the select operator selects a horizontal subset of tuples that satisfy the selection condition. So in other words, what we're going to do is only obtain rows that meet the condition that we specify. And here what we're looking at is just the basic form of a relational algebra select operation. R is a relation. Okay, so think back to our lecture on horses, and R could refer to the horse relation. The Boolean expression in the brackets is a selection condition. Okay, so these two examples, it could be last name equals Smith or salary greater than 3,000. Similarly, we could say the credits needed have to be greater than credits completed. So it is a condition that our rows must meet in order to be returned by the operation. Here we have our first example of the select operator. And what we're saying there at the bottom is we want to select all rows from the course relation that have hours equal to 3. And so the question we want to know is how many tuples will be returned, or what tuples would be eliminated when we run this select operator. Okay, so we run the select operator and we eliminate operations research, intro to economics, and database concepts. And the reason those are eliminated is because those rows do not have a number of hours that meet our selection requirement. We also have the ability to add more than one selection condition. In this case, we've added, in addition to hours equal 3, we've added credit must equal G to our selection condition. And the question again is how many tuples or what tuples will be returned? And of course, similar to when we had just a single condition, when we have the two conditions, we eliminate all rows that do not meet both conditions that we've specified. And so for this example, we've eliminated all of those courses with a credit equal to U, or rather credit not equal to G, and we've eliminated all courses that do not have credit hours equal to 3. In our previous example, our select operator had an AND statement. However, we can also use an OR statement, and that means that it will eliminate rows that do not meet one of the conditions. In other words, it will retain all rows that meet one of the conditions specified. So for this example, we're looking for those courses that are in the business college or engineering college. And again, we want to look for what rows we would expect to be eliminated or retained. Okay, so here we have the results of our select operation with our OR statement. And as I'm sure many of you expected, we eliminated the Intro to Economics course because it's in the Arts and Sciences College. In addition, we eliminated the Intro to Economics course that is in the Education College, as well as the Financial Accounting and Architectural History course. You may notice that Architectural History doesn't have a college at all, and therefore it also does not meet a requirement that the college must be business or engineering. But we do need to be careful with multiple operators. So on the previous slide, we used this first example, college business or college engineering, and hours greater than 2. And that is different from the second example where we say business or college engineering and hours greater than 2. And so in the first example, we do eliminate the operations research course because we've applied the hours greater than 2 requirement to both of the conditions in the parentheses. However, in the second example, we're applying that hours greater than 2 only to the engineering course. And as a result, the operations research class would not be eliminated since it is a business course and the hours greater than 2 requirement no longer applies. Next, we're going to take a look at this project operator. And as a reminder, the project operator selects a vertical subset of attributes from a relation. In other words, we're looking for a subset of the columns in the relation. And the lowercase pi is the symbol for project. An attribute list is just a list of our attributes that we wish to be returned from our relation R. The syntax for the project operator is very similar to the syntax for the select operator. In this case, we have R, which is a relational algebra expression, the most simple form of which is a single relation. But we may use multiple relations if we need to. The result of projection operation contains the attributes that are specified in the attribute list in the same order they are specified in the list. If the attribute list in a projection is not a superkey, that is, it's not unique, then duplicate rows will not be displayed. Okay, so here we have our first example of a project operation, and here we're saying that we want to obtain the columns from course that are equal to college. So we only want to return the college column from our relation course. Okay, and as I'm sure some of you suspected, the project operation to select college from course returns 5 tuples. It does include our null for the architectural history course. So it does return null rows. However, it does not return duplicates such as those for the business, education, and engineering courses. And here we have our second example where we are selecting name or projecting name from department. So we just want to get the column name from our relation department. And similar to our last example, when we project name from department, we do get 5 values returned, which is less than the number from the source relation because economics is duplicated and name is not a super key. And now we're going to get a little bit more complicated and see what happens when we specify multiple attributes in our projection condition. And here we see what the result of the name college department project operator is, and we get 6 values returned. And it's the same as for the source relation department, since name in college is a super key. And remember that a super key uniquely identifies each tuple or every tuple in the relation. And so every single tuple in the department relation is able to be uniquely identified by the combination of name and college. So that concludes our unit on unary operations. And in our next video, we're going to look at binary operations. Thank you. Enjoy the rest of your day.